The Hubble Space Telescope is our eye in the sky, and it has delivered some stunning images. The inner workings of the Hubble include a network of mirrors and lenses. A lens refracts light and focuses it on a point to form an image. There are three variables that are of importance with any lens. First, there is the focal length of the lens. This is the point in space where a lens brings an image into focus. The focal length is usually described with the letter f. The second variable is the object distance, in other words, the distance between the lens and the object you are looking at through the lens. The object distance is usually described with the letter O. The third variable is the image distance. This is where the refracted light from the lens produces an image of the object. The image distance is usually described with the letter I. This equation describes the relationship among f, o, and I. For the Hubble, the focal length is a fixed quantity, so we can rewrite the equation such that I is a function of O. This is a rational function that we can graph on the TI Nspire. Turn on the TI Nspire, create a new document. You may want to save a previous document. Create a Graphs and Geometry window. At the function entry line, input the function 57.6x divided by the quantity x minus 57.6. Press enter. You'll see part of the curve. Press Menu and under Window select Zoom Out. Use the nav pad and move the pointer to the center of the screen. Press enter enough times so that your screen looks like this. Notice the horizontal and vertical asymptotes. We can interpret these asymptotes in terms of the abilities of the telescope. For the function, the value of x equals 57.6 is not allowed, since this would result in a 0 in the denominator. As the value of x approaches 57.6 from the right, the value of y approaches positive infinity. As the value of x approaches 57.6 from the left, the value of y approaches negative infinity. When you move an object in front of a lens, the object distance changes. When the object distance equals the focal length, this corresponds to the asymptotic value. At this value, the lens does not produce an image. This is why mathematically an object distance equal to the focal length is not defined. Because the Hubble Space Telescope was built for deep space observation, then the object distances are vast. You'll see that as x increases in value, the y value, the image distance, approaches the horizontal asymptote. To see what the value is as x approaches infinity, rewrite the equation in this form. Now you can see that as x approaches infinity, the term with x in the denominator approaches 0, and the value for the image distance approaches the focal length. How well does the Hubble do with nearby objects like the Moon and other objects in the solar system? As you can see, as x approaches 0, the image distance increases or decreases in value dramatically. The image distance is not as stable as it is with distant objects. Here is another problem with nearby objects. This diagram shows that the angle measure of an object through a telescope is based on the size of the object and the distance of the object, as well as the size of the telescope lens. The angle is measured in arcseconds, where 3600 arcseconds equal 1 degree. The Hubble's resolution is 0.05 arcseconds. This is a very small angle measure and one that benefits from long distances. This is why galaxies are clearly visible through the Hubble. Galaxies are both huge in size and very distant, which take advantage of the Hubble's optics.